Good morning, grade 9. How are you today? Our lesson today is the Algebra 2, Chapter 5, Lesson 2. We're going to continue lesson of yesterday, multiplying and dividing rational expressions. Yesterday, we introduced the rational expressions. It is the quotient of two polynomials. A rational expression is a quotient of two polynomials. Other examples of rational expressions include the following, like x squared minus 4 over x plus 2, like 10 over x squared minus 6, like x plus 3 over x minus 6. How we simplify the rational expressions is simplify it and then identify any x values for which the expression is undefined. We learned how to simplify by the normal way of simplifying, and we said that when we're going to simplify the exponents, we divide the exponents, we subtract them, and then don't forget to write the last sentence in the problem. The expression is undefined at x. The value of x here and the value of x in the denominator, don't forget to write it. The expression is undefined at x is equal to 0. Here I have, when I factored, I have x plus 1, x plus 4. So x here, its value will be -1, and x here, its value will be -4. So I'm going to write the expression is undefined when x is equal to -1 and x is equal to -4. So whenever I'm going to factor and I will get the value of x, I'm going to write the expression is undefined at x is equal, then I'm going to write its value. Now we're going to go to the next page. We're going to solve example number 3. Before we're going to solve it, we have steps that we have to follow before we solve. Multiplying rational expressions. Number 1, factor all numerators and denominators completely. Number 2, divide out common factors of the numerators and denominators. Number 3, multiply numerators and multiply denominators. 4, be sure the numerator and denominator have no common factors other than 1. Let's watch a video here.
Expressions. Really, there's nothing going on here that we haven't seen already when we actually multiply rational numbers. We take a look and see if we can actually simplify a little bit, and we actually combine like terms. We know how to multiply rational expressions. We just multiply numerators, we multiply denominators, see what's going on. Of course, if we can simplify first, it makes our life easier. Let's check out this example. So here I've got this rational expression multiplied by this one. I see that, in fact, we can simplify, because here I've got w cubed in the numerator, w squared in the denominator. That means I've got 3 copies of w, 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 w. Oh, it's like the internet. www dot. All right, and then the denominator, I just have w, w. So that means that 2 of the numerator's w's can actually simplify with the denominator. Or you could think about it as w raised to the 3 minus 2 exponent. Or just w.
What is he doing now? He's simplifying. What is he doing now? He is simplifying. He's finding the w's up and down, the x's up and down, the numbers up and down that he can simplify together. As we said that the first step, factor all the numerators and denominators, divide out the common factors of the numerators and denominators. So he's searching for the common factors up and down, and he's simplifying them.
To the first. In particular, these 2 w's can be simplified away. With 2 of the w's here, I'm just left with 1 w on top. Okay, and here also, if we take a look at this, I can actually simplify one of the x's here with one of the x's here, and I'm only be left with 5 x's here. So after that little simplification, we can now actually produce the product of multiplying everything through. So if we multiply everything through, what do we see? Well, I see 3x squared times 20 x to the 5th. That's in the numerator. And in the denominator, I see 4, and that's been already simplified away, times 21 w to the 4th. Oh, and I made a typo here. Did you see the typo? Let's review. I've got 3x squared, but what about that one lone w? See, I forgot to write that in. Where were you? Huh? I didn't hear you. Okay. You claim you yelled out? I'm sorry, I didn't hear you. So I'm going to write that in right now. There it is. So there's the first numerator multiplied by the second numerator. There's the first denominator multiplied by the second denominator. Good. Okay, now I'm happy. Now you might say, hey, why didn't you actually multiply 3 times 20 and all that stuff? You can. You could say 60 up here, and you could say 84 here. But actually, I'm going to see if I can simplify, and I like the numbers to be small. So actually, I don't multiply until the very end. If you think that's silly, then great, and then don't do it. But here, when I look at this, I see that I can cancel and simplify this 3 with this 21, and I just get a 7. This 4 can actually be divided into 20, and I just get a 5. And I see that little w that I forgot to write in there actually can simplify with one of these w's here, and I'm just left with 3 w's downstairs. And so now when all is said and done, here comes the hardest part of the whole deal, is to see what's left over. So let's check it out. The coefficient is a 5. And what's left? I've got x squared times x to the 5th. For multiplying, what do we do with the exponents if they're the same base? We add, and so we see x to the 7, right? Because I've got xx here, and I've got x, 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 so I have 7 x's together. Divided by, what do I have downstairs in the denominator? I've got a 7, and then I've got w to what exponent? The 3rd. So after all is said and done, this product is equal to that. Let's try another one together. I'm showing you lots of detail here. And when you do these, on your own, like for homework or in classes, I bet you'll do it a little bit faster maybe, but I just want you to see how I think about it. You know what I mean? It's not sort of let you slap. Am I being silly? I don't think so. All right, let's take this product right here. First thing I would do, honestly, is I would see if I can simplify these things by factoring. So whenever possible, I love to factor. I love the factor. So in the numerator, I've got not much going on. X plus 3. Now I'm going to write this in parentheses because I'm multiplying, so I've got to multiply all the quantity here. So I multiply that by x plus 6. If you didn't put the parentheses, you might sort of forget that you've got to do all that foiling if you actually want to actually do the multiplication out live. So you always want to group things in parentheses when you're multiplying. In the denominator, I see I can factor out a 5. Let me actually do that right now live. So that's going to be an x plus 6. And let me just tell you, to be honest with you, I'm already feeling a tingly feeling in my stomach because I can see already I'm going to get a cancellation right there. See? So the cancellation gives a tingle if you let it. This is a perfect square, difference of 2 perfect squares. So it's x plus 3. I'm getting a tingle. And x minus 3. No tingle. All right, well now armed with that, again, I just took the product of the denominators, since I'm taking the product of these two rational expressions, and notice that I put parentheses around everything.
Girls, as you see here, he got out the common factors from the denominator. 5x plus 30. 5 is common here and here, so he get it out. 5 to be x plus 30. 30 divided by 5 is 6, so he got out 5 as a common factor. X squared minus 9, difference between 2 squares, so it will be x plus 3 and x minus 3.
Lots of tingles. And when all the tingling is done, I think we're left with, now, what are we left with in the numerator? Some people would say 0, which is a great mistake. What's really there? There's actually an invisible 1. Invisible 1 is a multiple of everything. If you put 0, then the whole thing would be 0 and you lost it all. So it actually is a 1 divided by 5 times x minus 3. This is a mistake on purpose. Can you see what the mistake is? This just says 5x minus 3. But really I want the 5 multiplied by everything. You've got to put parentheses around that. So that's how I'd write the answer. But if you want to actually expand that, you can distribute and say 5x minus 15. Either one's correct. If you want to know my favorite, I kind of like this factored. Always like it factored. Always like it factored.
Okay, girls, let's solve our examples that are maybe like the other two examples that like in the review. Multiply, then assume that all expressions are defined. A, I have here 2x to the power 4, y to the power 5 over 3x squared multiplied by 15x squared over 8x to the power 3, y to the power 2. What is the first step? Factor all the numerators and denominators completely. Divide out common factors. So let's factor all the numerators and divide out the common factors. What is nice here that they colored here what will be common together. What is the common factors together? They colored by the same color. Like, if I will take x here, I have x to the power 4 up and down. I have here x to the power 3. And I have x to the power 2 and x to the power 2. What about cancelling here x to the power 2 with x to the power 2? Orange and orange together. I cancel orange and orange together. So left for me x to the power 4 and x to the power 3. Up and down here. That's why they color it blue and blue. Orange and orange cancel together. So left for me x to the power 4 and x to the power 3. What is left here? X to the power 3 is all cancelled, and left for me here x to the power 1. Why? Because when I simplify or divide the exponents, I subtract x to the power 4 and x to the power 3 as if I have here, I will show you, as if I have here x, 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 and here I have x, x, x. Here I have 4x and here I have 3x. So the 3x will be cancelled and with the 3x up, so left here 1x, left here 1x. So x to the power 1. The same I'm going to do here for the y. Y to the power 5 and y to the power 2. That's why they color it in green. Y to the power 5 and y to the power 2. Let me write it here. For example, here I have y to the power 2 2y, and here I have what? And here I have y, 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 and y. 1 2 3 4 5 y. Let me put it here. So 2y and 5y. So the 2y, cancel the 2y from here. So what is left? Y to the power 3. Y to the power 3 is left here. Y to the power 3. No negative here. Y. Okay. So I finished the x, and I prefer that when you finish, you cross and you write what is left for you here. Let me write it in A. When you have finished, what is left here? Y to the power 3. And here what is left here? X to the power 1. And what is cancelled? You have to cancel so you will not get confused. This is cancelled, this is cancelled, this is cancelled, and this is cancelled, and then I have y to the power 3. This is cancelled and I have x. What about the coefficients? I have 2 and 8. I can cancel the 2 to be 1 and the 8 to be 4. Okay, 15 and 3. 15 divided by 3. Yes, I can simplify. So I'm going to cancel the 3. It will be 1. And the 5 will be 5. 15 divided by 3 is 5. And don't forget to cross so you will know the new answers. What is left for you up? 1 multiplied by y to the power 3 and x, don't forget it here, and 5. So if you're going to write it in order, write the coefficient first, 5, x, y to the power 3. What is left down for you? 1 multiplied by 4. I write it down. And here you got your answer. What we're going to do here in example B, x plus 2 over 3x plus 12, x plus 4 over x squared minus 4, 3x plus 12. My eyes here found a common factor. What is the common factor here? 3 and 12. Yes, 3 is a common factor here, so I will take it out. And I will divide here by 3. I will divide by 3 and I will divide by 3. So it will be, I will take out the 3. So 3 divided by 3, they will cancel each other. So it will be x is left for me. 12 divided by 3, 4 is left for me. X squared minus 4, difference between 2 squared. I can factor it to x plus 2, x minus 2. Here I got the new terms after factoring. X plus 2 can be cancelled by x plus 2 here, and x plus 4 can be cancelled by x plus 4 here. What is left? 1 is left up. Don't forget that 1 is left up, and 3 is left here, and x plus 2, x minus 2 is left here. So I can write it 1 over 3 multiplied by x minus 2, and I can distribute 3x minus 6. This one is correct. This one is correct. Now we're going to move to the last section in this lesson, that is dividing rational expressions. Dividing rational expressions. Let's watch a video. Okay, girls, we have here another example, solving simple rational equations. Solve. When I find solve, solve means find the value of x. Find the value of x. So x squared minus 9 over x plus 3 equals to 7. So what I'm going to do, I'm going first in the numerator to factor. X squared minus 9 is difference between two squared. So I'm going to simplify, to factor it into x minus 3 and x plus 3. And I'm going to cancel up and down x plus 3. So left for me, x minus 3 equals to 7. What is different here that I have here equals to 7. This is different here. So this means that I want to get the value of x. Here, what I'm going to do here, I have also equals to 5. So I want to get the value of x. So I'm going to do all the steps. I'm going to factor, or if I have a common factor, and then I'm going to cancel it. Then all the steps, then by the end, the last step, I'm going to find the value of x. X squared plus 3x minus 4, if I'm going to factor it, if I will say negative 4, which two factors, if I'm going to multiply them, they will give me a negative 4, and if I add them, they will be positive 3. And the two factors are negative 1 and positive 4. So the two terms will be x minus 1 and x plus 4. So x minus 1 will be cancelled by x minus 1 in the denominator, so left for me x plus 4. So x plus 4 equals to 5. So when I subtract minus 4 from the two sides, so x will be 1. Okay, thank you girls for listening. Don't forget to answer the homework of today. Thank you. See you tomorrow.